All right, chapter 6 is an important chapter. I know last week 4 and 5 was a lot to take in, but chapter 6 is kind of like the foundation of everything we're going to do for the remainder of the course. It's the foundation of statistical analysis because most of the formulas we use in the statistics world, especially this course, must be normally distributed. So we're going to go through chapter 6, which is about the normal distribution and how we show things are normally distributed so we can apply the statistical analysis we're going to learn in chapters 7, 8, and 10. We also have to verify these things for 9 and 11, but we're only going to do 7 and 8 and 10. All right, so the first problem I want to show you here in the homework is kind of how to read the table. And I'm going to show you how to read the table as well as solve this problem. They're going to be a little bit different. So for the first part, this is a z-table. So the problem will either give it to you, so this is the negative side, right? As you see, all your z-scores are negative. So the formula, like I put in the announcement, PDF, is your event x minus your mean divided by your standard deviation, right? And the reason we do that is just to use the tables, because I can take any problem that is normally distributed and I can therefore give it a mean of 0 and a standard deviation of 1 by calculating its z-score. If you use technology, you don't have to calculate z-scores because technology can actually calculate for any normal distribution. The reason this was used is before technology, because a normal distribution is very challenging to calculate using calculus, and that's what you have to do to find probabilities. So someone came up with the tables. Well, now with technology, we write computer code that does the calculus for you. Your TI-84 does the calculus for you. Excel does all of it for you. So you can just get to the answer and you can skip the z-score step. But if you like to use the tables, I will kind of discuss this real quick on how to kind of use the table. So after you calculate your z-score, so say we got a z-score of negative 2.14, right? So I need to always write my z-scores to 2 decimal places because my column here is in the ones place and then the tenths place, 1 decimal place, and then my top row is my hundredths. So if I have negative 2.1, so that's, and I come over here, so I'm in this row, and there's my 4 because the first one is 0, 0, so here's my 4, and I come down to negative 2.1. Oh, there it is. And I come back up trying to see it. I don't think, let me see if I make this a little bit bigger. You can see both rows at the same time. There we go, perfect. Negative 2.14, then the answer would be 0.0162 or 1.62%, right? These are percentages inside. Z-scores are events. As you can see by our graph, here's our bell curve, our normal distribution. It's centered at 0 because it is a standard normal. It has a deviation of 1. And there's where my z is. So if I'm on a negative z-scores, my z is to the left of 0. If I am to the right, that's where I use table 2. Now you can see I am to the right, and all these probabilities are higher than 50% because over half of the graph is covered. So again, inside the table are probabilities, percentages. The outside are the z-scores, which are events. So to do this problem, remember this is a percentile. So it's asking for the 4th percentile, right? Now, I know it's kind of tricky here. It actually wants you to find the 4th percentile to the right. So if you open up your table, it's asking for this piece, the white piece, not the blue. The problem is everything here in the table is to the left. So if I have a 4%, remember this whole thing goes to 100%, that means I need to find 96% in here somewhere. So I got 95, 95.99, 96.08. This is closer than this. So this is about 0.96. So I come over here, I got 1.7 and I scroll up 5. So my answer should be 1.75, 1.75. Now, if you don't like remembering all that, the easier way to do this is because a bell distribution is symmetric, I can find 0.04 here in the table. 0, 4, 1, 8, 4, 9, 4, 1. And you can see this is negative 1.75. But because it's to the right, I just make it positive. Right? That's going to be really key next week when we get into confidence intervals, when we're counting critical values, because you're going to have to find critical values. So this is how you find critical values. Just remember, we want the positive side. Now, if you don't want to use tables anymore, let's solve this problem. In Excel, you can type in equals norms with the S inverse. All right, norms, no dots, norms S inverse, and it wants the probability, right? Well, remember, this is a probability, so I can just put in 0.04, and I get the negative 1.75. Or, and you just make it positive, or you can make this 0.96, and you get the positive 1.75. All right, this is the key. Norms inverse is when you know the percentage and you want to go backwards. So, let me go back here. Oh, this one will work. It's the same one. All right. It wants you to find with a 0, 1, so that means I'm standard normal again. Draw a graph that finds the P14, the 14th percentage, and it says right here, separating the bottom 14 from the top 86, which means I am on this graph. Here's the bottom 14 and the top 86, right? However, it wants the bottom. So this is shaded the wrong side, so it should be this one. So you gotta be careful with that. Shaded is what you're looking for. And this is good now because I am to the left of that. Right? And since I'm finding to the left, I can use the tables. The problem is this one doesn't give you the tables. So you have to either pull out your book, Google a table to bring it up, or use technology. So, again, if I just do equals norms inverse, because I know a percentage on the 14th percentile, it wants me to find the event, the X or Z score that goes with that. So then I just put in 0.14, and I get negative 1.08. And this one should be negative because it is shaded to the left. All right, so that's why I always say draw a picture. So if I was actually doing this out on paper, I would draw the bell curve. I would shade what I'm looking for, and then you can put P14 here, or you can put an X, you can put a Z, you put a question mark right here, because that's what you're looking for. And if you're looking for things on this axis, you're looking for events, and therefore I have to use the inverse function. The reason I use norms with an S is because it is standard normal, and I know that because I have a mean of 0 and a deviation of 1. If I go back to another problem here, I now want to find the probability, so draw a graph to find the probability of bone density test score greater than negative 1.86. So this is great. Here's negative 1.86, greater than goes, but it stops here. I don't want it to stop. This is a positive. I don't like him. This is a negative. Perfect. But it's shaded the wrong way. That's less than. I want greater than. So it has to be D. My negative 1.86 greater than means shade to the right. I am shaded to the right. Now to find the probability, now I know my event. All right, and because it is a 0, 1, I don't have to calculate a z-score. That is my z-score. So again, you can go to the table and find negative 1.86 in the z-score. All right, and then you can kind of go over. So we'll do this in a sec for one more time for my table users, but preferably just use technology. So now, let's scooch this over so we don't have to cover up so much. If I put equals norm dist, norm, sorry, with an S, because I want the standard normal, so I want the one with the S. They only use this when you have a 0, 1. And it says I want negative 1.86, so that is my z-score. And I get that probability. I'm going to raise backwards so you can see. So norms with the S dis, I put in my value. However, Excel is just like the tables. It reads to the left. So since this is to the left, I actually need its complement. So I do equals 1 minus, equals 1 minus my previous answer. And this will give me the answer to the right. It wants 4 decimal places. So I got over too far again. So 0.9686. So this is where chapter 4 comes in handy. You got to know which way you're coloring. If it's to the left, you're good. If it's to the right, it's 1 minus. If it's in between, you have to find both of these scores and then subtract the bigger from the smaller, right? And I explained all that in the PDF. So 6.1 is all dealing with standard normal. So you should always use norms, inverse, or the tables. Like I said, I'll show you how to do this with a table one last time. So I'll go back to 8 because it had a table for me. So remember our score was negative 1.86. I'm just going to type this there so we can see it. If I come to my table, I find negative 1.8 and then I go over to 6. All right, I get 0.0314. 0.0314. You'll still have to do 1 minus because this graph only does left hand. So Excel just speeds up having to use the table. You still have to do the same concepts. All right. So now save this. Go to the next homework of 6.2. Let me find a problem here to do in 6.2. Because so 6.1, they already calculated the z-score for you. 6.2, you now have to calculate your z-score. All right, I'll let you guys kind of work through the definition ones. There we go. So they drew a picture for us, and it has the tables. Perfect. Here's a good one to start with because I can show you both ways. So bring up my Excel. Good. So find the area of the shaded region. So they actually did it for you. So here the mean is 100, which they didn't put on here. So when I draw my table, I actually put 100 right here in the center. Then I put my standard deviation written over here on the side, and then I put my X, and then I color. Right? So what they should have here is a 100 right here because it's the center. I'm going to the left because they tell me to, and my standard deviation. So because I don't have paper, I'll calculate my z-score here. So z equals, and the formula is, and I put in parentheses, it's your x value, which in this case is 95, minus your mean, which is 100, and then you divide by your standard deviation, which is 15. Oops. Always got to put equals in Excel to get it to become a calculator. So there is my z-score, negative 0.33. So if I click on my table, because table 1 is my negatives, and I find negative 0.33. So negative, well, I know I'm going to start here with 3 so I can keep my thing lined up. So I'm 3 in the hundredths. I come down here, and there is my 3. So negative 0.033 is 0.3707. 0.3707. So there's how you use the table. If I want to use Excel, I can skip that step because in Excel it's the same thing. It's norm, but you pick the one without the S because it's no longer centered at 0. It's now centered at 100. So I put norm dist. I put in my mean 95. I put in my standard my mean of 100, my standard deviation of 95, and then I always put in a 1 because that means I want the cumulative. And in the continuous world, we always want the cumulative, unlike chapter 5. It equals, why did we get a different answer? We should, oh, it's because this is more accurate. Let's see if it actually takes my, no, I can't check it now. All right, find similar question. All right, just change it to 70 because I want to verify that this is going to take both answers using the table and Excel. So I'll put in 70 now, 100, 95. Oh, that's what I put wrong. I put in my X instead of my standard deviation. Let me go back and see if we got the same answer now. No, I can't remember. Well, we'll do it twice since I put in my wrong thing. So remember, it's the X, the mean, the standard deviation, not the X again. So in this case, my answer is 0.023. Oh, what's 4 decimal places? 0.0228. 0.000228. All right, so let's verify the tables are right since I screwed this up before. So I'll change my table. So my new X is just 70. My mean is still the same, my standard deviation. So I get a Z of -2. come here, 0, 0, because there's nothing, so negative 0.0228. Perfect. So I messed up the last piece. I'm not going to recreate the video so you can make sure you learn from my mistake. When you put it into Excel, it is, delete all this again, it wants your X first, 70, and then it wants your mean, 100, and then it wants your standard deviation, not your X again. I put the wrong number in. My standard deviation is 15, and then you put in a 1. Perfect. All right. So make sure you type slow, unlike me, who kind of probably going too fast. So this is another one where you can go inverse. So before, you would have to do norm's inverse, but because we're not centered at 0 anymore, you want to use norm without the S inverse. You see you have to put a little bit more in. I have to put in my probability again, which is the shaded region, which is 0.99. I put in my mean, which again is 100. My standard deviation, which is 15. And this time I don't have to put anything else in. And this is what's so good about Excel. It tells you everything you have to type in. I hit enter. 134, round to 1 decimal place, so 134.9. To do this using tables, you actually have to do algebra now. You have to go into the table and find 0.99, which is actually the positive side, because you can see how much is shaded. So let me do this. So 0.99 and 0.9990694,901 right there. That is 2.3. Should be 3. Yep, 2.33. I'll type this right here. And then you have to set it equal to, you don't know what X is, minus 100 divided by 15. You have to write this on your paper, and you have to basically take 2.33, multiply it by 15 to bring it to the other side. This is where I say if you don't remember algebra, you're going to have to remember it. And then he's over here. Then I have to add the 100. Oops, again, Excel, you need an equal sign to do calculations. 1.3495, which is the same answer we got. A little bit higher, again, because of it wasn't precise. Excel will find the exact point. Tables is rounded, because you notice we didn't find 0.99 in the table. We had 0.9901. It should take both answers. If it doesn't, please let me know. Let's find one more, because if you can get through 6.2 and 6.3, the rest of the chapter kind of falls in place. Perfect. Here's an in-between one. So if I draw a picture, so draw my bell curve, whoop, my mean is 105, so it's centered at 105. And then I put on my axis a 91 and a 119, and I shade in between. So to solve this using technology, I know I have to take the bigger minus the smaller, like I put in the PDF. So I'm going to do norm, dist. I'm going to put my bigger X in, which is 119, my mean of 105, my standard deviation of 15, comma 1. Bring this over a little bit. And I'm going to subtract the smaller one, so I put norm dist again, parentheses, my smaller x, which is 91, mean of 105, standard deviation of 15, 1. Now just tell me I forgot a parentheses. And I get 0.06493, right? So I type in, bring this over a little bit, 0.6493, but that's a 5, so that should be a 4. I know it's a little fast, but the good news is this is a video, so you can rewind if you see what I have to type in. So let's go into another homework assignment. Again, and for that homework, if you want to use the tables, you have to calculate a z-score for every single problem. All right, 6.3.6.4 homework. So 6.3 is a little bit about that simulation. I'm not going to have you kind of do any of the math for 6.3 because it's just to prove 6.4. The few questions in here about 6.3 are basically definitions that you understand what your symbols are, right? most of the homework math questions in here are going to be 6-4, right? So, and you can tell this says 6-4. 6-4 is the central limit theorem. The only difference with the central limit theorem and everything that we have been doing up to now in the video is we've randomly sampled one thing. Central limit theorem says if I take samples from a normal distribution or any distribution as long as I take a large enough sample, typically larger than 30, the distribution of my means, my sample means, will always be normally distributed around the population mean, so whatever the mean is, right? In this case, the mean is 202.5. And the standard deviation divided by the square root of how many I pick. That is what the central limit theorem says. And if you want to see the formulas, go pull up the PDF. I have them in there. Or in section 6.4 talks about them. So, for this problem, find the probability that an individual distance is greater than, so an individual, this is 1. So this is part A is 6.2. So I draw a picture, bell curve, and then I can label my mean, label my standard deviation, label 215, color to the right because it's greater than, and then I come into Excel and I do equals norm without an S because it's not a standard norm because it has a different mean than 0. My X value is 215.9. My standard mean is 202.5. My standard deviation is 8.6. And I have the CDF. I hit enter. And there's my answer. However, this is colored to the left. I need colored to the right, so therefore I have to find its complement equals 1 minus my answer. And I get 0.059, I'll type this in here, 0.0596. Now, the difference is part B. The probability the mean number of 15. Now I'm picking more than 1. So now I have to apply the central limit theorem. So my mean is still the same. It's my standard deviation that changes. So my new standard deviation is going to be my old standard deviation of 8.6 divided by the square root, so in Excel that's SQRT, of how many I'm picking, 15. And there's my new standard deviation. So now I do everything I just did before, right? Again, it's a greater than, so equals norm dist. And then I'm going to put in my X of 200.3, my mean of 202.5, and I have to use my new standard deviation I just calculated. So not the old, the new. So I'm just going to click on that cell instead of retyping it all in. You can retype it in if you want. Put a 1. And I get an answer of 16.1609. However, again, this is to the left. I want to the right. So equals 1 minus my left. And I get 8391. So 0.8391. And that's how you do the central limit theorem. The key with the central limit theorem is if I pick only 1, that's 6.2. If I pick more than 1, that's the central limit theorem, and I have to find the new standard deviation. That's the only difference. All right, if you're doing z-scores, I just use my new standard deviation. So I do my x minus my mean divided by this standard deviation. All right. Now, why can the normal distribution be used in part B even though the sample size does not exceed 30? So, central limit theorem says you need a sample of 30 to apply the central limit theorem unless the distribution you're sampling from is normally distributed. Well, it says right here, the overhead reach distance for adult females are normally distributed. Therefore, we can have a a sample size less than 30 because the original population has a normal distribution. So these are just all going to be 6.3, 6.4. So I don't think I need to do any more of those because again, you can see once you get the concept down, the only difference between 6.4 is you got to find a new standard deviation. And then finally, we go into 6.5, and I'm not going to do 6.6. I do talk about it in the PDF. There is really no reason, since we are now using technology, and you learned how to do the binomial last week, and if you use technology for the binomial, you can do any size binomial. The approximation of the normal of the binomials before technology was available, it was much easier to use. Still a good chapter to review, and you can read the thing, but as far as homework, quiz, and test, I'm not going to have you do it, because I'm just going to have you do the binomial distribution. So, let's see what we have here. 6.5. 6.5 is assess a normality. So I do go into talk about how to build a QQ plot in the other video. You can see in the homework, let's see if we have to build one. This is definition. This is already built. Just want you to build a histogram. Right, so we talked about, how to do that already from previous video. And this is how you construct a normal. Well, this one's going to actually have you build it by the way I did in the video. All right. So you can go back and review that video. So just to talk about normality, if you build a QQ plot, it should follow this dotted line, right? And it should look like, the solid line. Your dot should follow the solid line. And you can see here it doesn't. It kind of has this crazy curvature. And because it does, therefore we do not, our data is not normally distributed, right? If it did follow a straight line, then we would say our data is normally distributed. So the data is not normally distributed. The points in there are not reasonably close to a straight line. So the last question is going to have you build one. In the homework, second to the last question is going to have you build one. Right? And it's going to have you walk you through the steps. Again, if you want to, you can help me solve this or view an example, and you can kind of go through. If you want to see how I did it, then go look at the video for 6.3 and 6.4, where I talk about the theory behind 6.3 and then how to do the table on page 278 and 6.4. All right. Email me if you have any questions. Have a good week.